Good morning to all of you. So today we are starting the topic called cryptography, right? So is the slides visible, materially visible?
Yes, sir, but something on the right
Yeah,
top.
that I will anyhow.
Okay.
Right. Okay. Now there is no problem, right?
Mm, I think
But
half of the
uh,
screen
but
is hidden.
yeah, no, yeah. Now I hope it is everything is okay. Correct.
Yes, sir.
Yeah. Okay. Um. Yeah. Right. So cryptology consists of cryptography and cryptanalysis. Okay, so the diagram also you can see here. Right. So cryptology is divided into cryptography and cryptanalysis, right? So the word cryptography derived from Greek cryptos meaning hidden, graphe means to write. So cryptography is art of science concealing the meaning of confidential communications from all except the intended recipients, right? Cryptography deals with breaking secret messages. So, but we are not in much into crypto analysis, but this is also needed to make whatever the crypto system we make, we need to see how far it is good, right? It is possible only from the crypto analysis. Right? Cryptography generally contains three things: symmetric ciphers, asymmetric ciphers, and protocols. What are protocols? Protocols are generally like key exchange protocols will be there, right? And also knowledge proofs. So in that protocol means it is set of rules and communications between two parties. It is not just sending and receiving something, not like that. It is a continuous communication between two people. For example, in key exchange, so key exchange protocol. So we will they interact so sometime back and forth. So finally key will be exchanged. So they called protocols. And symmetric ciphers and asymmetric cipher. These are the main types. Symmetric is also called private key cryptography, and asymmetric is called public key cryptography, also another name. Okay, so mainly we are going to deal with this. Okay, in between sometimes we'll study crypto analysis. Yeah. Okay. So the main ingredient in the course is that plain text is the original message that to be transmitted in the secret form. Ciphertext is its secret version, right? A cipher is a method translating plain text to ciphertext. The key is explicit formulation of the cipher, so that the job of crypto analyst is to discover the key and then break the code. So crypto analysts are like people, they always try to extract the secret information. The process of converting plain text to ciphertext is called enciphering or encrypting, and converting device is called encryptor. Yeah. Right now, all encryptors and everything is decryptors are all computers only. The reverse process by the intended recipient who knows the keys is decrypting or deciphering. The encryptor and decryptor may be algorithms executed by people or computers. Thus, the method used by unintended receiver to recover the original message is cryptanalysis. So, crypto system is a system for encrypting a plain text to ciphertext using a key. Yeah. So these are some terminologies we will use. Okay, but we will repeat again and again. Yeah. So generally, this is the diagram, right? So Alice and Bob. So there may be a reason that A, B, C, right? A, Alice, B, Bob. Generally, Alice is a girl and Bob is a boy, right? And there is another person called eavesdropper. So his or her intentions is to get the secrets. Actual intenders are Alice and Bob. These are the main users. They are communicating, and Eve tries to get information without their knowledge. So it is illegal. Yeah. Okay. So these are the communication participants. Okay. So generally they are called entity or a party. Is someone or something which sends, receives, manipulates information. For example, Alice is a entity or a party. Bob is entity or a party. Eve is entity or a party. These are entities. An entity may be a person, computer, terminal, etc. Is it okay? Entity is clear? Yeah. Okay. So entity is either Alice or Bob or Eve. Sender. So for example, Alice is a sender. Okay. Is an entity now, right? Is a two-party communication which is a legitimate transmitter of information. Yeah. Receiver or Bob is entity in two-party communication which is the intended recipient of the information. Okay. In the protocol, receiver becomes sender also, sender becomes receiver also, right? An adversary, Eve, is an entity of in a two-party communication which is neither a sender nor a receiver, and which tries to defeat the information security service being provided between the sender and receiver. Various other names are synonymous with the adversary, such as enemy, attacker, opponent, tapper, eavesdropper, intruder, right? Interloper. All these are same names. Okay. Yeah. An adversary will often attempt to play a role of either legitimate sender or legitimate receiver. Okay. Yes. Any questions related to the channel participants? Is it okay? Hello, Pratik. Is it these terms are fine with you? Hello, Pratik. Okay. Suresh.
Yes, sir.
Yeah. Okay. So now coming to the channels, a channel is a means of conveying information from one entity to another. A physically secure channel or a secure channel is one in which not physically accessible to the adversary. Unsecured channel is one from which the parties other than those for which the information is intended can be reorder, delete, insert, read, something can happen. So the channel, this is a channel, okay? So usually that is insecure channel. So secure channel is one from which adversary does not have the liability to reorder or delete or read. Yeah. Any questions till now? Okay, no questions. So thanks. Okay, so those who joined just now, so we are started just now. So we given the definition of a plain text, ciphertext, key, encryption, decryption. Then we defined that who are the people involved in the encryption, cryptography. So they are called entity or a party. There is a sender, receiver, and adversary. Sender, receiver, adversary. Yeah. And channel called insecure or secure channel. Right. So what are the four major cryptography goals? Okay. So people believe that yeah, I think I'm not. People think that confidentiality, secrecy is the only objective of cryptography, but no. There are many things are there. So that I want to tell you, but there are four major goals are these. Privacy or confidentiality. This is the thing. It started actually, cryptography started with this. Now many other things are added. Data integrity, authentication, non-repudiation. So we try to understand, but we'll repeat again and again. It is not that, but try to understand today itself as much as possible. Yeah. So confidentiality is a service used to keep the content of the information from all but those authorized to have it. Right. For example, Alice is sending information to Bob. Only these two people only need to know the information, right? Other person do not they should not get information. That is idea. Confidentiality means. Secrecy is the term synonymous with confidentiality and privacy. There are numerous approaches providing confidentiality ranging from physical protection to mathematical algorithms which render data unintelligible. Physical protection means, for example, we send a letter, right, by post. It will reach you because you are sealed with it. So no one can remove the seal or something like that. That is called physical. Or directly go and give it to a person, right? Third person cannot take it. But right now, everything going on mathematical algorithms, right? Yeah. So is there any doubt in this confidentiality? Yeah. Sonali, are you clear with?
Yes, sir.
So only these two Alex and Babu only need to know. Other person should not get the information. That is called confidentiality, right? And data integrity. Data integrity is the service which addresses unauthorized alteration of data. What is the difference between these two, right? So even though the person adversary unable to hear or know the content, but they may change the data, right, between receiver and sender. So to ensure data integrity, one must have ability to detect data manipulation by unauthorized parties. Data manipulation includes such as insertion, deletion, or substitution. Is it clear? Amiya, is it okay?
Yes, sir.
Okay. Is the difference is clear? So in the confidentiality, just confidential. Even it is information is confidential, but there is a party, some person, they can manipulate the data without. So they will delete the data, they will add the data, right? So they will enter and completely remove the data, right? It happens, right? So that is called data integrity. So some portion is removed. So we are able to identify it. So why I'm telling, be careful about all these things. So earlier only objective is confidentiality, but now these things are also happening. So we need to algorithms for this one need not this job. Okay. So as we go ahead, okay. So these are much complex. Data integrity is much complex than the confidentiality. So the algorithm which is taking care of both also will be there. Yeah. Okay. Yeah. So I hope these two are you understood clearly. Next one is authentication. This is what day to day our life is also happening. So we need to take along with us PAN card or Aadhaar card. Okay. You are authenticated person, right? Banks and everyone is asking Aadhaar card. Okay. Or when you are writing exam, they will ask for a hall ticket identification, right? So in future, how do you do? So Amazon and all OTP will be created. So many things, you know, that day-to-day life. Authentication is a service related to identification. So this function applies to both the parties and information itself. The two parties entering into a communication should identify each other. Information delivered over channel should be authenticated as to origin, date of origin, date of data content, time sent, etc. Right. So, for example, you lost your wallet, somebody else took it, right? So, but even then, we need to know that it is actual person only doing, right? How do we do it? That's why we'll send OTP, right? Okay, only card, he got card, but he cannot know the password and all, right? OTP and all, then they will be cut. At least they cannot do the things. Yeah. For these reasons, this aspect of cryptography is usually subdivided into major classes: entity authentication, data origin authentication. So entity authentication means, entity means I told you person, right? So is the same, is the actual intended person is doing or not? Data origin authentication means, so it also in between data manipulation happen, data integrity. That's why, see, authentication will take care of data integrity as well. Okay. Yeah, of course, there are the different. So only you are looking for entity authentication, then it may not. But authentication is much stronger than data integrity. Data origin authentication implies provides data integrity. Yeah, so that I already mentioned here. Or if a message is modified, the source has changed. Okay. So is authentication is clear?
Yes, sir.
So I hope you are able to see the difference. Confidentiality only secrecy. Data integrity in between data manipulation should not be done. Even they do not know the information, they will try to change the data. Authentication is that who is actual sender, entity authentication, and also actually where it is started. See, for example, today is a holiday. Okay, somebody told, you will accept it. No, right? Only it comes from the vice chancellor or somebody, then only you will accept. Correct. So actually, from where it came from, or in between somebody in the name of VC send a mail, then you will see the signature below, right? So whether it is authenticated information or not. Yeah. So that is the data originated from where, right? Yeah. So it is sometimes information, there is no secrecy, but from where actually came from is very important. So it is maybe authenticated. Yeah. So this is one of the highest. Non-repudiation is a service which prevents the entity from denying previous commitments or actions. Right? You say that you ordered something from Amazon and later you say that I do not ordered it. Why you taken money from it? You give it back to me, something like that. Okay, I hope it is clear. It is a completely different purpose, right? You made a contract and later he will say that he denied. You made a payment, later he say that you not paid me, right? So we know that these type of things will happen in day-to-day life, right? Now, because of the Paytm and everything paying digital, then you cannot non-repudiation sometimes decreased, right? Am I correct? Yeah. Non-repudiation is service which prevents entity from denying the previous commitments or actions. When dispute arises due to an entity denying that certain actions were taken, means to resolve the situation necessary. For example, one entity may be authorized to purchase of property or another entity and later deny such a authorization was granted. The procedure involving trusted third party is needed to resolve the dispute. So we'll go to courts, right, later. So now they'll ask for evidences, right? So that's why now non-repudiation is also become important. Is it okay? The differences are clear. Of course, 100% need not be. At least to some 50 to 60% you are understood. That's fine. Is the four are different? Are you clear? Able to understand?
Yes, sir.
See, one of the thing is that later you realize that non-repudiation cannot be done by using the public key, private key cryptography. This is highest and this can be done by using public key cryptography. Yeah, authentication can be done both public as well as private. Yeah, these other things can be done both private and public, right? But non-repudiation is one thing. So actually, public crypto system gave in the chance. For example, digital signatures. All these are happening because of that. Of course, digital signature related to authentication also. Non-repudiation will take care of authentication as well. That is much better and highest. So you understand that why we need to, sometimes the public cryptography is very tough to implement, but even then are there any advantages, right? Advantages are there. So because of now day to day digital is happening, so we need public cryptography also has some applications. As you know, earlier Hardy told that there are no use of mathematics, number theory, but lot of uses. People say that okay, public crypto system, RSA and all crazy, we cannot use it, but they have a lot of applications now. Digital signatures and all these things are happening because of the public crypto system. Yeah, even key exchange will happen because of the public crypto system. But entire confidentiality, all things now, even now happening with the private key only. So you need to understand the differences, these four. So then you will characterize that in future, you yourself prepare one crypto system. Then you will try to see that which of these four it is achieving. Yeah, okay. The fundamental goal of cryptography is to address these four areas in both theory and practice. Cryptography is about prevention and detection of cheating and other malicious activities. Yeah. So this is what about cryptography. Now coming to the actual business. So till now, any questions do you want to ask? So these are the main areas. Entire course will depend on this. Okay. And these are the entities definitions till now we done. Okay. So encryption, decryption. It is a function. Encryption, decryptions are functions. What is a domain? For encryption, the domain is K cross P to C. What is K? Is the key space. Is the plain text space. Is the ciphertext space. Many times this key space and plain text and ciphertext space may be same. Yeah, so it will take inputs from K and P and give an output in C. So plain text, some key will do something. This function will do something to that and convert this to C ciphertext. Okay. Yeah. So this is the function. So encryption is a function. Okay. Encryption is a reverse part that is again as it is will be there. Ciphertext to plain text. So it key may be different key, K2 comma C to M. So is this definition is clear, Rutuja? Okay, Mehak, are you clear with the definition? Encryption, decryption.
Yes, sir.
Okay. So symmetric encryption. So this is general encryption, decryption. Now symmetric encryption is that. So here same key used both. Same means not exactly same. Little modification may be there. And that comes from the key only, right? That from that key only. Sometimes just K inverse, okay. But we do not say that it is much different from the, it is a function, okay. Function of K. So not much. So we'll use the same, people say that same key. Yeah. Since function, right? Function. Yeah. So, so decryption of key comma encryption. So encryption takes K key and message and it will give the ciphertext. D of K comma ciphertext is equal to the message. Yeah, this is what about symmetric crypto system or public crypto system. So asymmetric crypto system is started by Diffie and Hellman. Okay, so in this paper, famous paper, the two directions in cryptography. Yeah, so each recipient of the message has personal key. Here, this is different. Actually, at that moment, they mentioned and they gave very small examples, but they are not given complete picture. But entire idea is given to the all the community, maths and computer science, whoever. Idea is clear and it revolutionized. Because what are the problems in symmetric crypto system? So why they went into this, right? Can you say some disadvantages of symmetric crypto system? We'll again come back later. But are you able to say few advantages, disadvantages? Any one or two disadvantages can you tell in symmetric crypto system? So what is a symmetric crypto system? We need a key. Both parties need to accept it, right? Same key used for both encryption and decryption. That means before starting the converting your data, what is that they need to know, both the parties? Suresh? Both the parties need to know the key, right, beforehand? Am I audible?
Yes, sir, you are.
So both the parties need to know the key. So how the first of all key will be exchanged, right? That is the problem number one. Are you followed that part? Now can you say some more like that? Can you say one more disadvantage?
So this is just a guess, but I think the receiver can manipulate the data.
That is, yeah, you are correct. That receiver can manipulate the data. And that is what actually data integrity and all, right? Those things will come into.
So if we have a symmetric key, then data integrity, we may not have.
This is the purpose of symmetric crypto system is that mainly for secrecy at the beginning, right? Even in the confidentiality, what is the problem that we are checking? Yeah, you are correct that other objectives they will affect. That is true. See, somebody else took the key, right? Then the authentication problem also comes or not? Am I correct or not? Yeah. So the key because of the key properly went to the recipient, then that is one thing. Is there any other? Yeah, that is good. One point. Yeah, any other points? Are there any other points? We do K1. Then we will communicate to each other, and then no
Hello,
other
sir.
third person. Yeah.
Your
Yeah,
voice was
first.
breaking. What did you say? I couldn't hear.
No. What I want to say that. So in the symmetric crypto system, if I want to communicate with you, I will both of us will exchange one key, correct?
Yes, sir.
Now that key we will use it then between both of us and we'll exchange. But can I the same key can I use for other person also?
Same key for other text, you
For
mean?
example, no. See, between you and me, I'm using one key. We both exchanged one key. Now I want to send information to you. Then I am using the message and I am using this key and converting it into ciphertext and sending it to you. Right now, you both of us already have key. Now you decrypt it and you get the original message. Is it clear?
Yes, sir.
Now you want to send again, use the same key and you will send it, and it is a communication going between you and me. Okay. But now I want to send some information to Kanak. Then what is that? Then between Kanak and me, there is another key I have to use.
Yes,
Unless
sir.
if they use the same key, what happens? If I use the same key, then what happens? Anyone else can say something? Oh,
So can decode the message that was to come.
yeah. So what is that? What is the problem now? Can you say something now? You understand the context? What happens in a symmetric crypto system? With each person, I had to make a separate keys, right? I want to communicate with 100 people, then I need to have 100 keys because I cannot trust. Na? Same key I cannot use it to two places. See, it is similar to that, for example, passwords, right? Maximum times, of course, we'll try our level best to use different passwords, but it is not possible, right? Every time. Are you following? We will use the same password over two parties also, right? So there is a danger. Is it not? Okay. Okay, that is the problem here. So different people, I need to use different keys. Then I need to now make all the keys I had to keep and with whom, which one I am using. So generally passwords also sometimes we'll keep somewhere again. Is it okay, Kanak? Am I clear?
Yes, sir.
Yeah. So that is a problem. But these are all the problems. So they want to sort it out. So somehow they came up with a public key crypto system. In this case, what happens? Interesting thing is that the person, for example, Alice and Bob, these two people. So Alice, okay, want to send some information, right? So now Bob actually what he will do, he will create a key, but now key is not a single, it is an ordered pair. So public key and secret key or private key. So public key is public, made public. Anyone can use it to encrypt the data. But secret key is with him only. Now he is the only person will use it. No one knows it. He will not share the secret key with anybody. Right? Now anyone who since public key is known to everyone, so they will use the public key to encrypt the data. But now the person, the receiver, use the secret key to get the original data. So now how many keys are required to share with people? Only one public key, one secret key. Am I correct? Is it clear or not clear? Sonali, are you fine with it?
Yes, sir.
Yeah, what is that we are doing? So for example, I'll explain again, right? Okay, so for example, Alice want to send a message M to Bob. She encrypts M by use Bob's public key known as, so we'll denote it as BPK. BPK means Bob's public key, right? So entire thing I am calling as a key, Bob's public. And Bob decrypts the ciphertext by using his decryption keys, Bob's secret key. So now what we have, that entire thing, first encryption. Encryption is encryption of Bob public key and message. So now we got a ciphertext. This E of B, P, K, comma M is a ciphertext. Now Bob use secret key and we will get the original data. So mathematically speaking, so public encryption is called one-way function with a trapdoor information. Okay. So I am not going into details. So somebody wants to tell about hash functions and all, since topics one or two people not yet selected. If then I value at each and every, but difficult to get the pre-images when give the image. Am I clear? One-way function is clear.
Yes, sir.
What happens is that, for example, you take some natural number n, right? F of x equal to x cube modulo n, x cube modulo n, right? Now that function easily evaluate x cube and then we will do modulo n. But now I give the value, then what is its pre-image? Very difficult. Yeah. So similarly, many modular functions will do that job. So it is a practical information, then you can get the one-way function, we can get the pre-images. That is called trapdoor information. Okay, so trapdoor functions. So the goal is that how we'll convert, how mathematical problems convert into this trapdoor public key crypto system. Means one-way functions will create with some information, it becomes easy to get the pre-image also, trapdoor information. Yeah, That is the idea. That is the main crux of the problem. So even though they mentioned it, they're not given the public crypto system. They're not given that at that moment. Okay. So, in fact, these people depends upon one problem called discrete logarithm problem at that time. So mathematical problem, right? But they're not given. But later in 1990, they given it in 1976 something. So around 80s, 85 something, then RSA cryptography came, right? They're the first people actually implemented it. Then there is another person called Elgamal. Elgamal actually used their ideas to give another crypto system that is based on discrete logarithm problem. So basically, most of the algorithms in the public key cryptography related to either integer factorization problem or discrete logarithm problem. Yeah, they are one-way functions. But so, for example, I give a natural getting your factorization is difficult. That is a hard problem.
Hello, sir.
If I yes.
Your voice is breaking many times in between.
Yeah, actually, I am in some other place today. Yeah, here internet connection is not that good. Okay. Now I hope it is okay, right?
Yeah, sometimes it is fine, but it breaks.
Yeah. Okay. So then I'll go a little slow. Okay, I hope now this public crypto system idea is okay. Suresh, what about you? Are you clear with this?
Yes, sir.
Okay.
Hello, sir.
Yes, please.
But in this also, the receiver should have a key and other receiver should also have another key, that secret key, right?
No, but each one, each person maintains only one key. That's end the matter. He will share public key with everyone and secret key he will keep with himself or herself. For example, what you do, you will share your public key to the entire world, right? This is my public key announce. Then I want to send some information to you. I want to send, and Kanak want to send, Achila want to send to you. Then they will take your public key and message and will convert it into ciphertext. Will send it to you, right? Then no one else can get the information.
Okay.
Now you have your secret key. That key is only with you. Now you can get the information back.
Yes,
So
got it.
same public key, the public key which you shared, that is the only public user to cipher. But decryption is possible only with you, no one else. Now those people also, they also cannot decrypt, but they already have the message with them. Correct?
Yes, sir.
The person who is sending already have the message with them. So, but no other person can get it except the person. Yeah. Yeah, and another thing is that this technique is also used actually key exchange protocol. So I told you that three things now protocols also there. Protocol objective is different. So protocols are different. So protocols. So public key crypto system, public key, not see crypto system is different. Public key approach, that whatever approach that can be used as a protocols also. So first, before actually you will use symmetric crypto system while converting the sharing information. But how do you exchange the key? In the key exchange time, you will use the asymmetric key system, public key approach. So that protocol will be followed by using public. Yeah, that we will discuss slowly. Yeah. Okay, so the encryption scheme is to be breakable if third party, without prior knowledge of the key pair (ED), can systematically recover the plain text from the corresponding ciphertext with some appropriate time frame. So then we'll call it is a breakable. Okay. So these are the just terminologies, but you do not understand unless and until we will do some problems, right? Yeah. So we'll start now actually doing some problems. Okay. So this is very early cipher, classical ciphers. These are called classical ciphers. Now these are no longer in use for the security purpose, right? Now they are just um, so like playing treasure hunt or something. Yeah. But earlier they are used. These are used actually. Okay. In the beginning they are used. So for example, first cipher people say that Caesar cipher. Caesar cipher is that just adding 3 to the your plain text and do again subtract decrypting. So it is a symmetric crypto system. Yeah. So more general shift cipher. What is a shift cipher? So I hope you can see the table here. So we have the plain text X and key. We'll choose the one key only. Okay. So somebody can help me. Is it a public key crypto system or private key crypto system or symmetric or asymmetric? Yes. Yes, Rutuja. Okay, Pratik. Okay, Kanak. Okay, anyone? Suresh?
Sir, public.
It is not public key crypto system. No, it is a private key crypto system or symmetric. Why? We are using the same key, both encryption and decryption. You see that the same key we are using. So do not. So this is a function of k comma y. Of course, function may be different. D y minus k here, but I am using the same key. Okay. So this is called private or symmetric crypto system. Private or symmetric crypto system, not public. So key is only exchanged between the parties. Okay. So for example, Caesar cipher. So k equal to 3. What is the plain text? We'll add 3 to it, modulo 26. Right. For example, the plain text is Caesar was great. What is that meaning? So A, B, C, D, E, F. So we have these things, right? If you add 3 to it, A means 0. Let us say A equal to 0. You can see in the table, right? Right. So what actually we do is, so I forgot to add that. Okay. So there is a numbering, right? A means 0. 0 plus 3 is 3. That is D. Okay. Is it okay?
Yes, sir.
Yeah. So now C becomes F, A becomes D, like that. So Caesar was great. Now converted into ciphertext is this. This is the plain text. This is a ciphertext. Here I gave actually, sorry. A00. Now 0 will add 3, I'll get D, right? C means 2. C plus 2 is F. Okay. So like that. So ciphertext equal to plain text plus 3 modulo 26. Plain text equal to ciphertext minus 3 modulo 26, or that is same as C plus 23 also, right? Minus 3 is nothing but plus 23. So are you clear now, Suresh? It is a symmetric crypto system. We are using the same key.
Yes, sir.
So I'm using the 3 only. While ciphertext, while creating ciphertext, I'm using plus 3. While using plain text, I'm using minus 3. But the same 3 I'm using. So both new sender and receiver using the 3. So they already know. While creating, they will add 3. While decrypting, they will minus 3. So same key. So cipher done like this. Okay. then it is easy to crack, right? Not much complicated. Yeah. So this again, this picture, there is a card tax exchange, right? Tax stock exchange. There I took this figure. Okay. Yeah. Any questions till now? Okay. Now a little, that is what FN cipher. So please go through it and let me know you have some questions.
Hello, sir.
Yeah, now again problem came, na?
Yeah, and you can turn off your video. It will help with the internet, I think.
Maybe. Yeah, right. Thanks. Yeah, thanks. Yes, that will be a good idea. Okay. So FN cipher is FN cipher. Okay. So this is A times X plus B now. My cipher text Y came from my plain text is X. I multiplied with A, right? And then added B to that. That is called FN cipher. Okay. Decrypting also same key, but the key is to A comma B. Do not confuse with the public key, private key, and this is entire thing is one key only, A comma B. So AX plus B. Now decryption is, okay, Y is equal to AX plus B. Then what you do? Y minus B, right? Then divided by A, right? Divided by means inverse, A inverse. So what required to get this one? A need to have some property, right? What is it need to have? Small a. Mehak, can you say something? Yeah, Achila, can you comment about A? Is there a restriction on A? Is there any restriction on A? Yeah,
The GCD of A and 26 should be 1, 2 for A to be invertible.
Invertible, correct. So that is the one limitation here, but very good actually. Now this is see here when my A equal to 1, what happens? If A equal to 1, FN cipher is same as
Caesar's
shift cipher.
shift.
Caesar cipher is a Caesar cipher is a particular case of shift cipher when k equal to 3. This is the original, right? Just go to 3 words that side. But FN cipher is much general. So for you are multiplying and we are multiplying, and this is called translation, right? This is less a translation, but here we have scaling and as well as translation, scaling and translation, right? So right. So here, is also using the same key. So this is an FN cipher. Okay. So how many keys are possible in this first case? Can somebody tell me how many different shift cipher can be possible? How many different shift cipher are possible? Yeah, connect.
Sir, I think it will be 25.
25. Yeah. In fact, that also original one also there is no change in encryption decryption. You can take A equal to 0. Yeah. Is at least some change you require. Yes, 25. Right. Correct. Whereas here, can you say FN cipher? How many different keys space size? How many different keys I can? Yes, please.
5 of 26.
5 of 26 is okay, but there is a B also, right? Both A and B together key, na? After multiplying again, I'm translating also. So total how many will be there? How many choices for A? You are correct. 5 of 26. What is 5 of 26? 5 of 2 into 5 of 13. Okay, there are 12 choices are there for that, right? 1, 3, these 3. Yeah, so yeah, again, can you change your answer? How many FN ciphers can be constructed? Okay, Pratik. Hello, Pratik. Okay, so this is 26. Why 12 into 26?
You have 26 choices for B because B is in
Ah.
Z26.
B is anything. So for A, we have only 12 choices. So, and one more question to you, to how far you understand, right? What are these two actually? First of all, go to shift cipher. So what is shift cipher is doing? It is converting A to some letter, B to some letter, like that, right? Okay. What is the, so these functions are shift cipher, shifting simply. What is actually it is doing to the set? You know something, which function it is? It is a function, where to where? It's a function from where to where? Yes, please. So here you see that jet from jet26 and I am adding k to it, right? So what is this encrypt function is doing? It is taking element from jet26 and taking where? To jet26 only.
Z26.
Yeah. Yes, Kaustubh, go ahead, please.
Yeah, Z26 cross Z26 to Z26.
No, that is okay. That is one thing. But actually, forget about. So I choose the key. Now map from where to where. I fix, right? Generally, we'll fix the key. Na? In private key crypto system, we'll fix the key both the sides. Once I
Yes.
fix the key, then it is a map from where to where. You are correct. I am just writing what you said. Right? So E is a map from jet26 cross jet26 to jet26. It is clear. And now you fix this, right? Now you are changing this, you are fixing this. Okay, so here I wrote k comma x, so I'll write like that only. Now this k is fixed. Now this is changing, right? So then it is a map from where to where. So that I am now denote as ek. Ek is a map from
Z26 to Z26.
jet26 to jet26. Now can you say something about this function now? Ask some questions. Say something. I do not want to tell those things. Maybe one of you can come up. What is that you ask when you have a function? What is the natural questions you will ask?
1, 1 on 2.
1, 1 on 2. Is it 1, 1?
Yes.
Because each element goes to different element, right? So it is a 1, 1. Onto automatically, why? Onto, no need to check onto, why?
Finite dimensional.
So not finite dimension. Both are finite sets and they are same sets.
Yeah.
They are same sets and finite. That's why 1, 1 automatically becomes onto. So a function it is both 1 and onto is called what?
Bijective.
Bijective. That's okay. Bijective function is also called permutation, right?
Yes.
So it is, we are justly permuting so that people does not know the idea what is that we are sending. We are permuting the letters. Okay, so we permuted and kept ready with us, right? That is what this tables is telling, this diagram is telling, or this table is telling, right? Once you done that one, so automatically computer will convert your plain text to ciphertext and send it, right? It is just simply a permutation only. Yeah, one onto functions. So both are one onto functions, bijective functions, both encryption and decryption. Right. The same thing even here also, but it is much complicated, right? This is also one onto function from Z26 to Z26, but this is much difficult to know. Yeah. To understand it, I am giving an example. So we have a key space A comma B, 9 comma 16. 9 is relatively prime to 26, so no problem. So plain text is attack. So x1, x2, x3, x4, x5, x6, right? A means 0, right? X2 means T means 19. So from this table, you can check T 19, right? Yeah. So like that, we have this one. Now I want to compute A inverse, right? A inverse, let us keep for decryption ke liye, but for encryption, no need to find A inverse. Keep this. Why it is A inverse is 3? It is because 3 into 9 equal to 27. That is modulo 26 is 1. So inverse of 9 is 3. And you know that this is one of the important result in number theory we done. So A comma N GCD is 1 if and only if so there exists X belongs to Zn such that AX congruent to 1 mod N, right? This we will use several times, you remember. That is now handy. The units in Zn, right? Okay. Now what is Y1? Y1 is 13. Can somebody tell me how 13 came? Okay. Am I done any mistake? A into X plus B, X is 0, 9 into 0 plus 16, it is 16. Why I wrote 13 here? Do you have an idea? Am I done mistake? Okay, so some problems are given here. We check them. Yeah, so and also I gave the ciphertext, and you want to find the ciphertext, crypto analyze the ciphertext. Okay, that was created by a FN cipher. Yeah. So is FN cipher is clear or not clear?
Hello, sir.
Yes, please.
In this case, we have K, that is GCD of AB, right? So
No, that not GCD of AB. It is a ordered pair. A equal to 9 and B.
okay. Okay.
It is not GCD. So key is both A comma 9 to A comma B. Entire thing is key. See, I am multiplying X first. Plain text is X. So I multiplied first with A, then I'll translate. This is entire thing is called
Yeah, okay,
key.
sir.
Yeah, right. Maybe I done some mistake. So okay, so another cipher is called Wigner cipher. This has very nice crypto analysis. Somebody can take up as a topic also. Yeah. So another option is to use enciphering scheme developed by French cryptographer, a Wigner. So Wigner crypto system employs keyword W1, W2, Wn of length n and n shift ciphers, and each plain text block of length n. And so this is somewhat called block cipher to understand actually. So stream cipher and block cipher. Stream cipher, you take one stream, one key, one x1 for example, right? So are here you take one letter at a time and you convert it, right? C to F, A to D, like that. Stream cipher. So, but whereas in the block ciphers, you convert your text into blocks. Yeah, and first nice example for block ciphers. So I'll explain you this now, right? What it is happening here is that one more thing. What is happening here? It is a permutation, right? In FN and FN cipher and as well as shift cipher. And you see that the shift cipher is a part of FN cipher. FN cipher is more general. A can be, if A equal to 1, I'll get shift cipher. But here, so we will take one word, okay, W1, W2, Wn, word of length n, and then we'll apply this one to the text. So how? First, I'll explain with one example and I'll again come back to explain this. For example, I want to encrypt. Cryptography is fun. Okay. But what is my word actually? Cipher is the keyword. How many letters are there in cipher? 1, 2, 3, 4, 5, 6, right? 6 letters are there. So what is that I do now? My cryptography is fun also. I'll convert it into blocks of length 6. Others I can find with something else. If it is not a multiple of 6, I will add some extra bits, extra letters. Is it okay? Okay, my original letters are cipher, CIPHER. So these are converted into numbers 02, 08, 15, 7, 4, and 17, right? Now, how do you convert? You take the plain text and you will add these K to them. So now keys are changing. See, key equal to 2, 8, 15, 7, 4, and 17, right? So you see that PA plus KI, PA plus KI, right? So to help you, so since keyword is a 6-letter word, first we group the letters of plain text into blocks of length 6. So crypto 6 letters, graphy 6, and use fun is another one, right? Now apply ith cipher to letter WI. For instance, we consider the crypto. So the numbers crypto are C means 02, right? 2, R means 17, like that. Now key values are 2, 8, 15, 7, 14, and now we will add them. 2 plus 2, 4. 8 plus 17. Yeah, do modulo 26 also, if required. So the corresponding letters are becoming like this. Now the cipher text block. So crypto now converted into this part. Okay. Now similarly you do for graphy. Yeah. So finally entire your ciphertext becomes like this. Is it clear?
Yes, sir.
Yeah. So this is called beginner cipher. So same word keyword we will shift it. It is important to remember that FN cipher substitute very same letter C to each occurrence of the plain text P. Yeah, what is the difference in these two? So that is very important. So for example, if you look at here, right? So for example, here we have D, here also we have D. So you know that wherever we have D, what happens? Do you know something? It came from the same letter. You understand that? Hello?
Yes,
Yes,
sir.
sir.
Yeah, so it is the same. D comes from A that we know here, right? So for all of them, pre-image is same. But here it is Wigner cipher, it is not like that. Am I correct? Are you following that part? So here, so it may not correspond to the same. Yeah, that is one of the advantage with here. FN cipher substitutes the very same letter C for each occurrence of the plain text P, whereas Wigner cipher need not. Wigner cipher may substitute the same letter C for different plain text letters. So this is one cipher, Wigner cipher. Yeah. So Hill cipher is a generalization to this. Okay. So till now it is these are polygraphic ciphers till now, and this is different. So again, this is developed by Hill. Okay, how it will do? So you divided your plain text into some blocks again, right? P1, P2, something, right? So some block length size. Now you are creating ciphertext by combination of these. A times P1 plus B times P2 modulo 26. C times P1 plus D times P2 modulo 26. So to get C1, C2. Okay. But now AD minus BC comma 26 GCD is 1. This is only for, we can extend it to any block, any number of blocks. So this is a block cipher with n equal to 2. That's called diagraphic ciphers. Yeah, so I'll explain with one example. So your ciphertext message is that original message is slow and steady wins the race, right? What is that you are doing? You are converting it to first equal to 2, right? You took 2, 2, 2, 2 each. SL, OW, so A and DS like that. You convert into blocks of length 2. Okay, step 1. So replace each letter by cardinal number. S means 18, right? Like that you converted. Okay. Now the plain text P1 equal to 18 and P2 equal to 11, right? So my key is this 5 comma 13. These ABCD values, that matrix 5, 13, 3, 18. These are the important ingredients. So 5 into 18 plus 13 into 11, right? So 3 into 18 plus 18 into 11. So 18, 11 now convert into 25 and 18. Okay, like that we will convert everything. So this will translate to 25 means Z, 18 means S. So it will translate like this. Is it okay or not okay?
Hello, sir.
Yes, please.
Can you scroll up a bit?
Yeah. You want to see here this part?
Yes. Yes, it is clear.
What is that we are doing? Slow and steady wins the race. We divide into two blocks, right? Then we convert each of them into numbers. S means 18, L means like that. We convert into numbers. Then afterwards, so we took the first two blocks, 18 and 11, right? We convert into C1, C2 from these. But these 5, 13, 3, 18, these are, sorry, yeah. So these are the keys actually, right? A, B, C, D, A, B, C, D. These are the important. So we will apply the same 5, 13, 13, 18 to each and every blocks of length 2 pairs. So in general, how do you write this? C1, C2 equal to 5, 13, 3, 18, P1, P2. So 5 into P1 plus 13 into P2, 3 into P1 plus 18 into P2 modulo 26. Right? Yeah. So now this encryption function is the matrix 5, 13, 3, 18. So determinant of E equal to 51. 51 is relatively prime to 26. So now we can find its inverse D. D equal to E inverse. Okay. So then now I'll get a plain text from the cipher text by multiplying this in this matrix. So even though this E and D are different, but it is again E only, E inverse, right? So it is still symmetric crypto system only. Is it okay? Achila, are you fine with it?
Yes, sir.
Yeah. Yeah. So I'll ask one more. Mehak, are you clear till now? What happened? Hill cipher is clear.
Yes, sir.
So yeah. So I gave complete picture. Now it can be extended, right? It can be extended easily.
Hello,
You can
sir.
extend. Yeah, please. Yeah.
That P1, P2 will get, that is for the first two letters only, right?
First two letters only. Each time we need to do two letters. Yes,
Mhm.
correct. Yeah, correct. So we'll write a program, right?
Yeah, yes, sir.
So now see, original text is this slow and steady wins the race. Now converted into two. First we'll take SL and word SL I take first, right? SL I'm converting SL. Okay. So P1 is 18 and P2 equal to 11 SL. So P1
Yes.
is 18 and P2 equal to 11. SL I am converting into ZS. Now again I take another pair. So like that each pair I take and I'll convert. And decryption also similar. Go back. P1 P2 getting from C1 C2. Yeah, we'll get P1 equal to 18 and P2 equal to 11. Is it okay?
Yes, sir.
Yeah, good. Any questions? Please ask me. So this is called Hill cipher. Okay, this can be extended now. So n can be greater than or equal to 2. You divide, but you fix the n value. N is the block length. In the earlier case, block length is 2. Now you can create block length, maybe some say n blocks, right? So then we have, we get n by n matrix, right? But in n by n matrix is required. So this can be extended. So I asked one example for an exercise problem, right? So this is now we need to use this matrix to encrypt the data.
Hello, sir.
Yes, please.
So that E is a coefficient matrix, right?
Yes, quotient matrix. This is actually
Okay,
inside. This is the E. E is the function. See, what is this E is doing? This E is here 5, 13, 3, 18 quotient matrix exactly. That is the actual function. It takes plain text. It will give the cipher text. D is the E inverse. That is, it takes the again. It is a function. So this is invertible matrix. So invertible matrices are permutations again.
yes.
Yeah, right. So there are other ciphers available, right? Okay. Yeah. So others, somebody is writing. It seems. Oh. Okay. So let me take small break and we come back. Okay, just I want to tell you few more ciphers. So till now, many of them we are done are related to substitution ciphers. right? The main problem with the shift cipher is that number of keys is too small, right? Only 26, right? Including 0. So almost the same with the FN cipher. Of course, there are that 12 into 26. To increase the number of keys in the substitution cipher, right? So to write down the key for the substitution cipher, we first write down the alphabet and then a permutation of the alphabet directly below it. This mapping gives a substitution which make between plain text and ciphertext, right? For example, my plain text is this and the ciphertext is this. So encryption involves replacing each letter in the top row by its value below. So decryption involves the first looking for the letter bottom row and seeing which letter is the top row maps to it, right? So in this case, how many substitution cipher, how many possible keys are there? Yes, I'm just stopping and again doing. Can tell me that how many? Yeah, somehow that is why it is coming, I don't know. It is called substitution cipher, okay? Yeah, how many possible keys are there? Hello?
Sir, I didn't
And
understand what we are doing here. What does it mean to replace it by its value? Just like,
okay, nothing actually. See, I'm doing some permutation. You take some permutation, right? Permutation means what? Z26 to Z26 permutation means what? What is meant by permutation? Permutation is 1 onto map, right? You fix one permutation, right? So you map 0 to some number, right? Permutation means what? It is a 1 onto map. So A mapped to G, what is that means? 0 mapped to where? Some number, right? Are you following?
yes, sir, yes, sir.
So I took one permutation and then I converted. So reverse, you do the reverse operation, you will get the decrypting, right? So see, shifting also permutation, right? You understand that?
Yes, sir.
Shifting also permutation, but in this permutation, what happened? So it is a particular type of permutation, right? We are just adding 3 only, correct? See, if I give you, so 1, 2, 3, 4 and 1, 2, 3, 4. Okay. So I ask you to give a permutation. What you do? Some people will give that just 1 map to 1, 2 map to 2, 3 map to 3, 4 map to 4. Is it 1 onto map? Yes. Okay. But here, what is that we are doing? We are adding 0 to and modulo 4 we are doing, or modulo 5, whatever you can say. Otherwise, 0 to shuru karlo, then it will become easy for you. It is we are doing modulo 4. So 0 map to 0, right? Yeah. What is other map? Can you tell me?
0 goes to 1, 1 goes to 2, 2 goes to 3, 3 goes to 0.
Yeah. So 0 goes to 1, 1 goes to 2, 2 goes to 3, and 3 goes to 0. In this case, what is the function? You know the function now. What is that you done?
Adding 1.
Yeah, it is equal to f of x equal to x plus 1 modulo 4, right? So that is what we call a shift cipher, correct? Okay, but shift ciphers are a permutation. That part is okay.
Yes, sir.
But every permutation is a shift cipher?
No.
No, right? So how many shift ciphers are there? Just shifting only x plus b, right? X plus k, right? F of x equal to x plus k. So how many possible ciphers are there? So how many? Yeah, and it is equal to n possibilities or 26 possibilities, including 0. Identity map. Is it okay? I cannot have more than that. But these are the only permutations? No. Permutation means 1 onto maps. There are so many permutations are there. Okay, but these are also permutations. Okay, these are particular type of permutations. They have a nice formula. Similarly, FN ciphers also little general, little better, but there is a formula again, right? But total, how many permutations are there? That is the question here. Now, are you okay?
Yes, sir.
Yeah. Now, can you tell me how many substitution ciphers are possible? The number of possible keys. So, see, what is a key in the substitution cipher? So, not, yeah. You know the shift cipher, sorry, shift cipher. In the shift cipher, what is the key? You choose one key, K, right? That is one of the among 26, right? 0 to 25. Is it okay? That is called key. In FN cipher, what is the key? How it look like? In FN cipher, how key look like?
A comma B.
Wonderful. A comma B. B has a restriction, only 12 possibilities. B can be anything. So their key look like that. So once I give you A comma B, then you know how to do encryption and decryption. Do you know or not know?
Yes, sir.
We know. Similarly, in the shift cipher, once I give the key value, K value, then you know how to encrypt, how to decrypt, correct? Yeah. So now, but there is a direct, luckily, like formula is there. But why I need to restrict? I take some arbitrary 1 onto map. Then I know I and but between you and me, we know what is the permutation we done. Then I will do it. Right now, there is no formula. Are you okay? For that function, I cannot give a formula type. So I do some permutation. I put A map to G and I will not repeat. Arbitrarily I choose A, go to G, B, A, O. But I should not repeat, right? Because I need 1 onto map. Now, am I clear or not clear?
Yes, sir. Clear.
It is called substitution cipher. You are substituting A with G, B with, but there is only one problem that I should not repeat. So now can you tell me how many possible keys are there? This is one key, right? So I do some random permutation and I will send, okay, this is the way I done. I map 0 to 3. Yeah, earlier I just adding K and that is simply a permutation, but very clean formula is there. Just I need to give K equal, K value to you. But now I cannot give like that. I need to tell each entire function I need to tell you. Are you
Hello,
okay?
sir.
Yeah, yeah.
But key here is this random selection, right?
That is so I need to give entire function. See, for example, I have a function from domain D to some A to B.
Okay, okay. Got it.
When do you know the function? You know the function only when I know each and every point in the domain. Am I correct?
Yes, sir.
But I know that it is a shift cipher, then I no need to tell where 1 goes to, where 2 goes to, where 3 goes to, 4 goes to. No need to tell. I just tell that, okay, just add 3. Then that is the formula I'm telling. There is a nice formula is available. Similarly, FN cipher, okay, there is a formula, right? So I only need to know A and B, a function, f of x value, f of x function. But I map 1 to say 5, 2 to say 2, right? And 3 to 7, something randomly I do it. Now how I give the value, now how I will tell the key to you. In order to tell key to you, I need to tell each and every value where it goes.
Yes, sir.
Yeah. So Achila, I hope now it's completely clear. I hope so.
Yes, sir.
Yeah. So now how many possible keys are there now?
26 factorial.
26 factorial. So that is entire SN. Entire SN. Earlier shift keys and shift and FN are a part of SN, but they are not entire SN. SN is now 26 factorial. So basically, if you are very strong enough, then there is some techniques are there. Even then you can get the data. But basically, this is very tough, right? 26 factorial is very big number. You understand? Okay, what is that I want to say? So is it Caesar cipher is a tough to decrypt?
No.
No, right? Caesar cipher just we are adding. So after some time, we can easily figure out what is happening. Are you following?
Yes, sir.
It is not much complicated to know. With a little manipulation and some work, we will get it. In fact, all shift ciphers are easy to get it. That is what will happen in the treasure hunt and all, right? Again, FN ciphers also not that complicated, but it is little tougher than in compared to shift cipher. Okay. Now when come to substitution cipher, substituting. So I don't know, random, right? It is much tougher. 26 factorial is very big number. So that many keys are possible. Yeah. But there is a technique that we will not discussing now, but there is a technique that is called frequency analysis. What is that? So I'll tell you in the next class, but I'll just give you some approach now. English has something. Okay. English, one letter is more frequent than other letters. Do you know which letter is more frequent in English?
E.
E. E is more frequent. Okay. So then I'll see that which letter come more frequently. I'll think that, okay, this guy send this letter to E. With that frequency analysis, it is highly possible that almost will get it. So that technique I'll tell you later. That is called crypto analysis, where without actually knowing key, but I am able to get the key by using crypto analysis. Here frequency analysis. So that's why even the substitution cipher is very tough, but there are techniques. Their analysis is there. I hope I am done. I'm clear to you.
Yes, sir.
Yeah, good. But very tough actually. So substitution cipher is very good. It is called substitution cipher. So what we can say that so substitution ciphers are big. It contains FN ciphers. FN ciphers contains shift ciphers. Are you okay? Substitution cipher, every shift cipher and FN cipher is substitution cipher, but not the converse. Okay. Other cipher. Somehow these letters are. This is actually permutation cipher. So next one I'm talking about permutation cipher. Though I call there's substitutions of permutations, but here you take a particular permutation. The idea behind substitution type ciphers form a part of design and modern symmetric systems. For example, letter which we shall. So there are nice crypto systems, DES and AES. There is something called S-box. I will tell you at that instant. Okay, but it is better to tell now. Some students who are now start reading any textbook, they will understand that substitution ciphers, permutation ciphers are used actually. In our day-to-day life, right? Everything goes with the symmetric key only, not public key. Yeah, but they will use various type of things. Okay, it is not just one approach. They will follow different approaches. So you know that you will first cross one gate, then another gate, other gate, like that. Then you reach the treasure. Okay. So permutation cipher number of around for number of centuries. Here we shall describe the simplest one. Okay. What is the difference between cipher and cipher? Yeah. So you take some permutation, sigma, right? We first fix a permutation group Sn for a small value of n, and then we take a permutation sigma. The value of sigma, which will be the secret key, as an example is given below. Now some plain text say, once upon a time there was a little girl called Snow White. We break the text into chunks of 5 letters only. So remove the capitalizations, right? So 5 letters. Now we will do this. Are you able to see the difference between substitution cipher and permutation cipher? Though we are calling substitution cipher is a permutation, but permutation substitution cipher is a permutation of all 26 ciphers. It is a permutation of 26, but permutation cipher is only you take a particular n. Am I clear or not clear?
Yes, sir, clear.
Yeah, okay. What is that I'm doing is that now it is a block cipher. Substitution cipher is a stream cipher, but this is a blocks. We divide your information into blocks. Then you apply this permutation for each block. Yeah. So very good actually. This is also very good. So people use this actually. Permutation ciphers are very much used in the day-to-day life, in the data encryption standard and advanced encryption standard. In these, we will use these things. Yeah. So you will understand better, but I want to tell you I am introducing certain ciphers today. Yeah. But you will get bored if I introduce more and more, but one or two I will tell quickly. So people crazy some playfair system. Okay. So they will put your data into table. So playfair. So see, PLAYFAIR, like that entire thing they put into blocks and then do some operations. So we'll get a playfair cipher. Some other one is called some other cipher is there. Yeah. So these are certain ciphers are available here. Yeah. So I will give some time to go through it. Then I will stop with this. Okay. This is similar to that. Later you can understand this. Okay. Later. But I'll give some time to you. So as a small exercise now, read it and try to understand what is happening. Okay. So try to understand what is playfair cipher. Just you are reading along with me. Okay, so before going other people to participate, so one of you can tell up to this extent table, how table is formed. One of you can tell how table is formed.
So in the word fair, play fair,
Yeah.
the word A is repeated twice. So it has just written it in a 5x5 matrix where A is not repeated, and
Very
then
good.
the remaining letters where I and J is considered as the one letter.
Very good. Right. So now A already came, B not came. So B I started, B, C, D, E. F we do not put reason. F already there in the play fair pay. G, H, I we not put. So K, J also not coming because I and J are same. So I do not put that. So this is one technique they used, play fair cipher. Okay, somebody done like this. Okay, table is clear to all of you. Suresh, is it okay with you? Table is
Yes, sir.
cipher, just play fair. So A is repeated twice. So I remove that and then I'll convert into 5x5 matrix. So luckily, nicely it came 5x5 matrix. That may be the reason that he chose it play fair. Okay. Suppose the plain text is meet at the schoolhouse. remove the space, divide the text into groups of 2 letters. If there was a double letter appearing in the group, insert an X and regroup. Add an extra at the end to complete the last group if necessary. Our plain text becomes like this. So do you understand that? Or how our plain text becomes like ME? Why there is a OX here?
In the same block, there are 2 O's. So it says when there's a repetition, insert an X.
Right. Yeah. So these are some rules, okay, that they converted the ciphertext. Now use the matrix to encrypt each 2-letter group by following scheme. Yeah. So I'm just telling you that like that crazy people are so crazy. So you know that even IITs and many places they conduct the ciphertext competitions, so techno events, right? So they will give different types of these. There are websites actually, yeah, to create ciphertext, and so there are games also there one can play. Yeah. So now if the 2 letters are not in the same row or same column, yeah, you better you read not good. Yeah, now go through these 3 rules, okay? Just this is the last tip today, yeah.
Sir,
Hmm.
can you scroll up a little so we can see the matrix?
Is it okay? Still letters are okay or not okay?
Yes, sir. Yes, sir.
Yeah, so that entire thing can be seen. Yes. I'll do one thing, I'll extend it. Yeah. Is it clear? Or at least why ET converted into MN, is it clear?
Yes, sir.
Okay, see, yeah, so ET converted into MN because, yeah, can you somebody say? ET converted into M in MN, why? Because E row I take and T column I take. So E row T column, so what is the common point? That is M. right? And then why n came? So I take row T and column E. So that is n, right? So that way I will get the, so I'll change the letters, right? So then entire my original text, ME becomes EG. So why ME becomes EG? Let us check. How M becomes E? Somebody can tell me? So I had to take both M and E to convert M to some letter, right? So I take a row corresponding to M, and column corresponding to row corresponding to M, column corresponding to E. Yeah, what is that? E only, right? Yeah, so E now the same thing. So by G came, right? Okay. So E row and corresponding to column M. Why G came? I'm not clear about it.
Sir, we have to take the letter right to it, right? If it is in the same row. So M becomes E because on the right side there is nothing. So we take first and E becomes G.
Okay. Okay. Okay, fine. So it's clear. So similarly, we will use the decryption also. This other person, German person who created ADF GX cipher. Okay. So yeah, you can check that later. So I'll stop here. Yeah. Any other questions? So today just I given the some classical ciphers. Okay. I hope you are clear with the shift cipher, FN cipher, substitution cipher, and then permutation cipher. Permutation cipher is similar to Wigner cipher. You see, Wigner cipher also like this. Wigner cipher, right? Yeah. So, but we will use the permutation ciphers and very frequently substitution ciphers, right? Then play cipher is one small example how people are define different. So many this type of things will come. So one of you can pick up. So last time one girl picked up transcription cipher. So wrapping up and different techniques are there. I shared that slides with you. So one of you can take it, and that is related to again classical ciphers. Yeah. So today, in fact, I completed classical ciphers, right? So instead of extending it so many, so today everything is covered. So we do not put more time on this. But I want to tell you, one of you interested, then Wigner cipher ka crypto analysis is very good. This is people worked on Wigner cipher very big way. So literature is available, right? One can work on that if you want. I'll stop here.